institutions all over the world. But such closure has only accelerated the development of virtual platforms so that learning would not be disrupted by any manner. This pandemic is the major health crime and the greatest challenge we have ever faced since the Second World War. Before getting into our session,
Before getting into our session, here are some instructions. To improve the quality of sound functional during the meeting, please mute yourself when you are not sharing. If you have any queries during the presentation, please type them into the chat box. We will discuss them at the very end of the session. Your active participation is very important throughout the session.
moving on, I welcome all the dignitaries, guests, and delegates. I feel extremely privileged to extend my warm welcome to everyone present here for the webinar on the topic Remote Sensing in Agriculture, organized by the Bioscience Department, SciGuys, in association with IQAC of Indira Gandhi College of Arts and Science. Now, I invite the backbone of our department, our beloved HRD, Professor Jyoti C. Nair, for the official welcome address.
Good morning, all. I'm extremely happy to welcome all of you to this webinar, Remote Sensing in Agriculture, organized by the Department of Bioscience in association with IQAC. Before we get started, I would like to express my gratitude to all of you who cordially engaged to make this event come to a success, especially Professor Subi B.S., Professor Divya C.G., and Professor John Joseph. It's really admirable how you always see projects through from conception to completion. Moving on to my duty. First, I would like to welcome our Honorable Principal, Dr. C.V. Thomas, a man with clear vision, a continuous learner, one who adapts to new trends and stands out among his peers. Due to unavoidable circumstance, he could not join with us, so we know that your motivation and guidelines will help us to reach frontiers. A warm welcome to you. The webinar today is led by a great resource person, Dr. G. Baiju, Principal Scientist, Central Crops Research Institute, Thiruvananthapuram, who will be giving us a presentation on remote sensing in agriculture. Sir, on behalf of the college, staff, students, and all the participants, I welcome you. I also take pleasure in welcoming our Administrative Officer, Mr. Badusha Bashir, and our IQAC Coordinator, Professor Sajid A.M., who extend their support in running the entire program so smoothly. Next, my welcome goes to our teachers, who plays a vital role in the lives of children. They help to mold young minds and encourage students to challenge themselves on a daily basis. I would like to welcome all the non-teaching staff, especially Mr. Arun for his technical support. Last but not least, I would like to welcome the shining stars, the students of this institution, into this program. Once again, I cordially welcome all of you to this webinar. Have a great day. Thank you.
Thank you, ma'am. Now, I welcome the role model of our institution, our respected principal, sir, Dr. C.V. Thomas, for the principal's address. Unfortunately, our principal is having a very busy schedule. Moving on. Remote sensing is the acquisition of information about an object or phenomenon without making physical contact with the object, and this is in contrast to on-site observation. There are several types of remote sensing systems used in agriculture, but the most common is the passive system that senses electromagnetic energy reflected from plants. Agriculture remote sensing is not new and years back to the 1950s. But the recent technological advances have made the benefits of remote sensing accessible to more agriculture producers. Now we have the most eminent resource person, Dr. G. Baiju, the principal scientist of Central Tuber Crops Research Institute, Trivandrum, for discussing about Detect. He has acquired his graduation and post-graduation in agriculture from Kerala Agriculture University and took the Doctor of Philosophy in Soil Science and Agriculture Chemistry. He started his career as a scientist in ICAR NAARM Hyderabad in the year 1992. He served as a scientist in many institutions, and from 2009 to the date, he is working as the principal scientist in ICAR Trivandrum. His expertise extends from research on site-specific nutrient management of tropical tuber crops with more knowledge-intensive tools such as Queb's model, impact of climate change on suitability and productivity of tropical tuber crops using geoinformatic tools and ecological niche models such as eco-crops and boboost. He has presented 102 scientific popular articles, referred 98 journal articles, and authored 3 books and many more. He has been serving as a Fellow of Indian Society for Root Crops, ICAR, CTCRI, Kerala. He has been awarded Dhiru Moraji Memorial Award 2012 for the best research paper published in Indian Journal of Fertilizers during the year 2011. We are extremely delighted to have such an eminent personality. A very big thank you, sir, for being with us. A warm welcome to you. All to you, sir, please.
Good morning. Respected Head of the Department, Professor Jyoti C. Nair, other senior faculty, other participants who are attending this webinar. First of all, I am very happy and thankful to the college for inviting me to discuss with you for about an hour about the applications of remote sensing in the field of agriculture. So with this introductory remarks, I will start my presentation. Is my presentation visible to all?
Yes, sir.
Okay, thank you. So in the next 1 hour or so, I will be discussing about the applications of remote sensing in agriculture. We all know that agriculture is one of the oldest professions as well as the oldest enterprise and the most successful enterprise the human beings have been practicing for centuries. And agriculture, we know during the last year, 2020, has been passing through a very difficult time due to the biotic stress that humans faced due to the virus. And the data, very recent data, show that agriculture is the only sector that was resilient to this pandemic. And the agriculture growth in our country showed a positive trend, while all other economic sectors showed a negative trend. So this shows the resilience of our farmers and the cultivators globally with respect, in comparison to all other economic activities that human beings are practicing. And agriculture has passed through a number of transitional stages. Man started agriculture about 10,000 years ago, approximately, when he started growing settlements. And this process of farming has been transformed to revolutionary phases through the interventions of science and technology. And scientific farming, or what we can call chemical farming, or the application of fertilizers, pesticides, and other inputs started. It has got only a history of about 200 years, less than 200 years, because the first chemical fertilizer was developed only way back in 1840s, about 150, 160 years ago. And afterwards, there was a leap forward in the yield and production of all the crop plants. And we all know that green revolution in our country, which was started by late 1960s. The major interventions in the green revolution were high yielding varieties of plants, number one. Second, fertilizers. Third, pesticides. Fourth, irrigation facilities. So all this has resulted in a quantum jump in the production as well as productivity of the crop plants, which enabled our country. Earlier, we were waiting for the ships from other countries, especially the United States, to bring us wheat as well as rice. We were having a begging bowl, and now our country, this year's total production of food grain production is touching about 300 million tons. We are self-sufficient, and now we are exporting many of our products, especially rice, vegetables, and a number of products. So with this introductory remarks, these are some of the slides which show some contributions of Indian agriculture. Actually, Indian agriculture contributes 8% of the global agricultural gross domestic product to support, but our population is 18%. And this much 18% of the population's food need is supported by 9% of the world arable land. Our geographical area is only 2.3%, and our water availability is only 4% of the total global availability. So with these very limited resources, we are able to support the food and nutritional needs of 18% of the world population. And in this success story, enough technologies have enabled us in achieving all these targets and achievements. Now, we know that still we have a number of challenges that we are facing. And one of the most important challenges in Indian agriculture is that about 60% of the cultivated area is still rain-fed. So rain-fed agriculture has been passing through a very difficult time due to the climate change, especially drought, number one. Number two, high temperature. And number three is aberrations in the rainfall pattern. So all these are very seriously affecting the rain-fed agriculture, which constitute still more than 50%, more than half of the total area cultivated in our country is dependent on rainfall. So that is a major challenge that our country is facing now. Now, another challenge is the scarcity of land. We have only 0.13 hectare land per person. Our land per capita land is only 0.13. This is a little old data, which stands to get reduced to by 2050, when our population will be about 150 crores. The per capita land availability is going to be reduced to 0.09 hectare per person, which means that we need to produce more food from unit area of land. So all this necessitates the interventions of modern technologies and scientific and technological inputs. So in this respect, one of the most revolutionary contributions has been given by the smart farming tools. Smart farming, it is what you people, I think most of you are aware about smart farming. I told that we started farming, or human beings started agriculture about 10,000 years ago, but we started modern farming only 200 years ago. And in the last 20, 30 years or 40 years ago, with the developments in satellite technology, our agriculture has been turned into a lot of revolutionary, has made a lot of revolutionary changes in the field of agriculture. So smart farming, just like other fields of technologies, information technology has enabled agriculture to revolutionize production as well as productivity of many of the crops worldwide. So in this concept, this is also known as precision farming. Smart farming is known by different terminologies: precision farming, precision agriculture, satellite farming, site-specific crop management. So a number of terminologies are in use, but all this mean it is a smart farming. So my talk is, I will be discussing with you in another 40 or 15 minutes about the applications of remote sensing in the field of agriculture, especially in 5 or 6 major areas. And some of the areas where agriculture remote sensing has contributed are: number one is crop area estimation, number two is crop phenological studies, number three is yield assessment, number four is crop disease, insect and weed monitoring, number four is soil mapping, and next is climate change modeling. So these are some of the important areas where remote sensing has been applied very widely in the world. So remote sensing, before going into remote sensing per se, I would like to discuss with you for a few minutes about the broader subject of geoinformatics. Remote sensing is one of the three components of geoinformatics. So geoinformatics is the science and technology dealing with structure and character of spatial information, its capture, classification, storage, processing, portrayal and dissemination, including the infrastructure necessary to secure optimal use of this information. So in geoinformatics, there are three components. I think most of you may be aware about that. Number one is GIS, Geographic Information System. It is nothing but the software part that will be analyzing your huge data, satellite data or any other remote sensing data, or that kind of point data. So that is GIS. Then second component is GPS, that is global positioning system. For any geo or data analysis, you need to know the location information, latitude, longitude and altitude. So it is a system of satellites. India is also having a GPS satellite system. United States, actually they pioneered into this global positioning system. And we are still using the satellite system owned by the US. And that is the second component. And third is remote sensing. So remote sensing data, that is the data part that gives you the geographical data, lot of huge data, and that will be analyzed using the software platform that is called GIS. So GIS, GPS and remote sensing together, that branch of science that deals with the GIS, GPS and remote sensing is known as geoinformatics. Already I have told that it is the software part, GIS is the software part. It handles spatial information, it analyzes spatial information, and it retrieves a lot of data and interprets the data into, it will be converted into useful outputs. Now, I may not go much deep into all these aspects because it is a general topic for about 1 hour. So, spatial and descriptive data, geographic data, in remote sensing and in geoinformatics, you will be analyzing geographic data. Geographic data means any data that is attached to a specific location, that is called spatial data. Now, this I have already discussed. What are the components of GIS? So in GIS, Geographic Information System, you can analyze a number of layers. So it stores information about the world as a collection of different thematic layers. You have a real world, you may have a land use system existing in your location or city or district or country. Then you may have another layer, thematic layer of population density, then road, then other supply systems. So all these different layers can be stacked, and the GIS system will help you in analyzing all these layers together in one platform that may not be possible by human beings. And this concept is not a new concept, GIS. It has a history of more than 50, 60 years. When there was an epidemic in London, a cholera epidemic, and this one gentleman, Dr. John Shaw, he first used this concept to identify the origin of the cholera. And by locating the water pumps as well as the cholera deaths, he could be able to understand that the cholera and all this death happened due to pumping of water from a specific well. So this was the origin of the application of GIS concept. And a number of GIS softwares are available. The most famous and the most powerful software is ArcGIS, that is very costly. For one license, it will be costing more than about 10 lakhs, 10 to 15 lakhs of ESRA US. Then ERDAS Imagine, Idrisi, Clark University, Geomedia. So left side column shows commercial products. But nowadays there is for researchers and academicians, we can use a number of free and open source softwares. Most popular ones are QuantumGIS, Open, EV, GV, SIG, ILVIS, GRASS. So all these are free and open source. You can just download from the internet and you can use for most of your research applications. Now, second component is GPS, Global Positioning System. It is nothing but your, even now, you all know about GPS because it is available in your mobile. You are using for your day-to-day purchase, for Swiggy, for all this kind of purchase, you are using all this remote sensing applications. So just now, everybody knows about the applications of remote sensing and GPS and GIS. So your location, your house location is noted, and it will be home delivered. So all these things are happening. That is the most popular application of geoinformatics in our day-to-day life. So when I was a student about 30 years ago, when our teacher used to teach this science of geoinformatics, remote sensing, GIS and GPS, we used to look at each other and ask what is the use. It has no application. We are not finding any application. But now, after 25, 30 years, we find that this is the one of the most one of the most disruptive technologies that has penetrated into even to the lower segments of the society. So you can every time when you are hiring a taxi, when you are hiring an auto, when you are buying food, when you are online purchase, all this use the applications of geoinformatics. Your map data, your location data is there. So that is the most important visible spread of this technology. Now coming to the third aspect is remote sensing, about which we are talking in a little detail today. So remote sensing, so any collection of any data or any information about an object without a direct physical contact with the object, that is called remote sensing. A very common remote sensing is your photograph. You are taking a photo with your mobile camera. It is a remote sensing. So you are collecting information about an object without being in direct physical contact with the object. But the most popular ones are satellite data are there. Then aerial photographs are there. Then this our ground photographs are also there. So all these come under the purview of remote sensing. So more precisely, a scientific definition is the acquisition and measurement of data or information on some properties of a phenomenon, object, material by a recording device not in physical intimate contact with the features under surveillance. So this remote sensing uses different devices which are sensitive to electromagnetic energy. Like number one is light energy. Cameras and scanners attached to satellites, they use light energy. Then thermal scanners are there where heat energy is used. Then in radar, radio waves are used. So all these devices are sensitive to electromagnetic energy. So in a remote sensing technology, there are different components. The most important component is in passive, especially in passive remote sensing, our solar energy. The most important source of energy is sun. Sun is the solar energy. Then we will have a target on the ground. That is the target. From then the satellite will receive the electromagnetic wave from the target, whether the satellite or aerial photograph or unmanned aerial vehicles, whatever it is, they receive electromagnetic waves. Then from there, the station and the ground station will receive and process electromagnetic waves data from satellite. So you have the satellite data. Then comes the analysis part, the GIS part, analysis and interpretation, image processing of remote sensing data. So these data are in huge volumes, and you need a very big or a very powerful server computer like computers to analyze. If you want to establish a geoinformatics lab, you need server computers, very big storage facilities, because if you download a remote sensing data, it will be in huge volume. And finally, spatial analysis, and last part can be modeling and interpretations. So these are the components of remote sensing. Now this is a fundamental, most of you are aware that this is about the electromagnetic spectrum. The visible range is a very narrow range, 400 to 700 nanometer, but if you see the entire electromagnetic spectrum, it has got a very wide range of wavelengths. And we have infrared, we have microwave, FM, AM, long radio waves. Now coming to the shorter side, we have ultraviolet, X-rays, gamma rays. So each part of this electromagnetic radiation has got applications in your day-to-day life. For example, visible part, you all know, we are able to see whatever we are seeing with our eyes. That is the visible part of the radiation. Then you have microwave radiation you are using every day at your home, radio waves, your radio captures. Then ultraviolet radiation is emitted by sun, and you get sunburn when your UV index in the solar radiation is very high. X-rays are used in our medical field. Then all these levels of or ranges of electromagnetic radiation has got applications in different fields of our activity. Now coming to the applications of remote sensing in agriculture, I would discuss about 5 or 6 areas where it can be applied, along with some case studies, just for you to understand. Very quickly I will be passing through. Number one, the most important application of remote sensing in agriculture is crop area estimation. Crop area estimation. It is very important to estimate crop area well in advance. When a crop is in the field, for example, in our country, rice, wheat, for many of the crops, this is being practiced. It is not in theory. It is being practiced. As soon as the crop is raised, as soon as the rice is planted, or as soon as wheat is planted itself, before its harvest, we are now estimating what is the acreage, what is the estimated production that we are going to get, whether it will be sufficient, whether we need to make arrangements to import any food crops or other pulses, oil seeds. So all these are being actually really practiced in our country for quite a good number of crops, mostly rice, wheat, oil seeds, etc. So so crop area estimation is very important, and it is very widely practiced in remote sensing. So you must all remember, number one is area estimation of crops. So a number of methodologies, different tools, techniques are there that we will not discuss much into detail. But the basic principle of crop area estimation is, you know that if you see the structure of a leaf, it has an epidermis, then it has got a mesophyll part, and you have also the vacuoles. All these components are there. So cellular leaf structure and its interaction with electromagnetic energy, this figure shows, and most visible light is absorbed, while almost half of the near infrared energy is reflected. So in this, here you can see that in the case of it shows the reflectance, percentage reflectance, how much is reflected in different part of the electromagnetic spectrum. You have the visible spectrum, 400 to 700 nanometer. First part is visible spectrum. Then you have near infrared reflectance also. And the most basic theory is that for most of the vegetation types, the reflectance is very low in the visible part, and the reflectance is very high for near infrared part of the electromagnetic spectrum. So vegetation has a low reflectance in the visible region, and they have got a high reflectance in the NIR region that is shown in this figure. That is the basic principle. But if you see the different spectral features of a green leaf, here, this is a very typical figure of the spectral response characteristics of green vegetation. So you can see that in the visible band of the spectrum, that is 0.4 to 0.7 nanometer, light absorption by pigments dominates chlorophyll absorption. Chlorophyll absorption is dominated in this visible part of the electromagnetic spectrum. And there are two main absorption bands. One major absorption band is in the blue, that is 450 nanometer, 0.45, and another one is in the red part of the electromagnetic spectrum, that is 670 nanometer. That is shown by two arrows in the figure. Left side, you can see chlorophyll absorption. 400, 450 and 670 nanometer due to the absorption of the two main leaf pigments, chlorophyll A and chlorophyll B. So these are the two strong absorption bands that induce a reflectance peak in the yellow-green band. Now, another important point is in addition to chlorophyll, there are other leaf pigments also in many leaves, and these have different absorption bands in different parts of the spectrum. So leaf pigments, then cellular structure, they have a higher reflectance from beyond this visible range. Yellow to orange red pigment, if the leaf contains yellow to orange red pigment, for example, some leaves are carotene colored, so that has a strong absorption band in the 350 to 500 nanometer range and is responsible for the color of some flowers, some fruits, as well as some of the leaves without chlorophyll in the autumn season, winter season, the leaf color changes. All this will affect the absorption bands. Then the red and blue pigments, the xanthophylls, some leaves have got more of xanthophylls. They have a strong absorption band in the 350 to 500 nanometer. So the basic principle is the absorption bands differ with the leaf color, leaf structure, and all these things. And this will be distinguished in our GIS software, and that is the basic principle by which different species or different crops, or even within a species, different varieties are identified. Now, a number of indices, a number of tools are used to distinguish crop from another crop, because especially in our countries like India, it is, except for rice or wheat and some other crops, many crops are grown. In one parcel, you may have tapioca. In another parcel, you may have turmeric. In the nearby parcel, you may have maize. So we need to distinguish one crop from another crop very clearly, for which a number of tools have been used. And just I am introducing to you it's a very conventional and very old one of the tools, that is called NDVI, Normalized Difference Vegetation Index. So in Normalized Difference Vegetation Index, actually what we are measuring is, we are subtracting the reflectance between values between near infrared region minus a red region divided by sum of the reflectance. So it is the difference, it is actually the difference between reflectance values in the visible red and near infrared wavelengths by overall reflectance, that is the sum. Sum will give the overall reflectance. So this index is very widely used to distinguish crop plants or different plant species in a particular area. And in theory, the normalized difference vegetation index measurements range between -1, because it is a ratio, sum divided by difference, -1 to +1. But in practice, the measurements generally range between -0.1 to +0.7. A number of factors will affect this index, like cloud, water, snow, ice. Also, all this will affect the NDVI values, and sometimes you need to get remote sensing data on cloud-free days, and time series data will be required. A number of intricacies are there in analyzing satellite data and estimating the crop area. So this NDVI has got a lot of applications, not only in crop area estimation, in measuring the vegetation cover, it is used. It is used in crop assessment studies, that is very widely practiced. Then weekly vegetation maps are available. Then monitor crop over large regions, monitor vegetation change in much of the tropics. So it's biomass estimation. A number of applications are there for this index NDVI using remote sensing data. So in city CRI, I am working in Central Tuber Crops Research Institute, which is under Indian Council of Agricultural Research, ICAR, Government of India, New Delhi. City CRI is mostly working on tuber crops. The most important tuber crops, number one is, cassava or tapioca, commonly called tapioca. Internationally, this is known as cassava. Then we work on sweet potato. Number two, it is a major tuber crop in India. Then we work on taro, colocasia. We work on elephant foot yam, Amorphophallus peonifolius. We work on yams, Dioscorea. There are three species, Dioscorea alata, Dioscorea esculenta, Dioscorea rotundata. And also we work on a number of other minor tuber crops like arrowroot, Chinese potato, etc. So here I have some of my PhD students, two of my PhD students, and one MTech student has worked in this aspect, in this line, and they have developed some methodologies for acreage estimation of cassava by remote sensing. Actually, two methods. Earlier, one MTech student, she worked and developed a method using a Landsat satellite imagery, and the methodology used was possibilistic CME. There are a number of methods are available. So with this, she could be able to estimate the area, total cassava area in Tamil Nadu in two districts, I think in one district. And also two varieties were able to be distinguished. The most popular variety is H226 and another variety is Mulluvadi. So even in the same species, two varieties could be very clearly identified using remote sensing methods. And another methodology later on, very recently, and one of my PhD students, she developed a method for estimation of, again, cassava acreage estimation, because technologies and tools are advancing and changing day by day. Nowadays, I repeat, we use AI-enabled artificial intelligence is now being used very widely in interpreting remote sensing data. A number of artificial intelligence tools are available. One of the widely used artificial intelligence tool is SVM, Support Vector Machine. So in this study, we have developed a methodology to estimate the area of cassava using remote sensing data and AI algorithms, artificial intelligence algorithms. And based on this study also, we developed a methodology for cassava area estimation, and the accuracy was very near, it was very high, very good accuracy. Could be observed using many statistical tools like kappa, coefficient and all. So this is about the first application of remote sensing crop area estimation. Number two is crop phenology. So what is phenology? Phenology is actually the study of the timing of the different biological, each crop or plant will have certain phenological critical stages of growth. So the timing of recurring biological events in plants. What are the causes of their timing with regard to biotic and abiotic stress, and the interrelations among phases of some, so the different phases of growth of a plant. That is crop phenology. It has got, for example, leaf unfolding, flowering of plants, when it will flower, fruit ripening, how many days it will take after flowering to fruit ripening. All these are fixed. So then color changing, leaf fall, or these are some of the examples of crop phenological events. The task of plant phenology is to observe and record the periodically occurring growth stages and to study the regularities and dependency of the yearly cycles of development and environmental conditions. So crop phenology, why it is used in agriculture? Because mostly for scheduling of agricultural operations, like irrigation, like pest management, or nutrition, when to give nutrition. So all these are dependent on certain phenological stage of the crop. So plants vary. When there is a drought, when there is a frost, when there is a pest attack, there can be changes in the phenological stage. So, for example, the total life cycle of a plant gets shortened if the temperature, if the average temperature increases by 0.5 degrees Celsius or so. So during high temperature, there will be an early maturity. So based on this, you need to design or devise the different agricultural operations. Then frost warnings, there can be frost at the end of a season or when there is fruiting. Then there can be drought warnings. So all these, then pest control warnings. All these are, for all this, the study of crop phenology is very important. Then pest forecast models based on meteorological and phenological data. A number of pest forecast models are now very widely practiced. For example, some of you might be aware about a very serious problem of mealy bugs, a white powdery coating you can see in most of the plants, especially during summer. Now, if you go around and see most of the plants, papaya or even coconut, then leaf, guava, vegetables, tomato, brinjal. If you see the under surface of the leaf, you can see the spiraling white fly, white powdery like pest attack, then mealy bugs. So all this, the prevalence and the spread of all these pests or some diseases depend on weather and phenology, crop phenology. So a number of models are now developed, and with this now we are very able to very accurately predict the pest, whether the pest will be infesting in another part of our country, whether is there any chance to infestation of a pest by March in Karnataka or in Salem district of Tamil Nadu. So all these kind of predictions are now possible with very clear accuracy with the support of remote sensing data and this kind of models, pest loss models. So this crop phenology, understanding the crop phenology has got a lot of applications, even in climate change studies. Change in the population density, longer growing season, earlier plant flowering, plant may flower early during high temperature. So all these need information about the phenology of the crop, for which remote sensing has got a lot of applications. So with respect to in the field of agriculture, the providing phenological data as an input is very important for different crop models. As I have told, pest loss model, a number of crop models are now available. So in all these models, modeling work, you need to input a lot of phenological data and timing of management activities. In addition to agriculture, crop phenology has got a lot of applications in ecology, natural resource management, education, gardening, human health. I am not going into the details of all these areas due to time shortage. Now coming to just a small case study, just a show to understand how we can, or what is the application of monitoring of phenology. For example, in the case of wheat, winter wheat, this is a study published in a journal. So they used the satellite data, NVSAT, MERIS data, and data were pre-processed, NDVI were calculated. Then some other basic data were also used, land use, land cover data, land use map. So using all this as input, they made a study. Their observation was 2 kilometer, 5 kilometer by 5 kilometer experimental area were selected. This is a study conducted in China. 25 points were observed. Key phases, phenological stages of winter wheat, such as heading stage, flowering stage, harvesting dates were observed. And these data were used not only to calibrate the model, but also to validate the monitoring results. So this is a flow chart that shows the methodology that they have used. Now the result, just if you see the result, just in this map, just you see the first left side image shows what is the date of heading. Heading means the emergence of the inflorescence. What is the heading date of winter wheat in a particular province in China? You can see it differed. Just understand that the date of the emergence of the inflorescence differs from one within a particular province, and based on that you will be able to assess when will be the harvest time, when will be the next planting date and all. And second, right side it shows another province. So heading date map. So here in the left side, in the right side, Henan province, a general trend of earlier in the eastern region and later in the western region would be observed. So heading is earlier in the eastern part of that province and heading will be later in the western part of that province. So the earlier heading date appears in a big area of southeastern Henan at the end of March. So all these are very important in taking decisions by planners and policy makers. So this is the second application. First one was crop acreage estimation. Second one is crop phenological studies. And third, the most important is yield assessment. I told in the initial, along with the crop area estimation, I have told that even in our country, in India also, now we are forecasting the yield. Very accurately, we are able to forecast the yield of rice, the yield of wheat. When the wheat is planted in Punjab, Haryana, or when rice is planted in Punjab, Haryana, Orissa, and all these places, before the harvest, that is called yield forecasting. Before harvest, we are now able to very accurately predict how much our country is going to produce by the end of the Kharif season. How much, what will be our production by the end of Rabi season. When we are able to know this, if our production will be excess, we can go for export, we can make plans. If our production is going to be less than the actual requirement, we will be able to take decisions on import. So all this need well in advance or in season crop data. So in this field, remote sensing has got a great role to play, and they are actually doing yield prediction and production forecasting, production potential reduction in crop yields, or which enables us to allow timely import or export decisions. Yield prediction or production forecasting. Conventionally, some of you may be aware, conventionally we used to, the people by person, they used to conduct some surveys. It is called a crop cutting survey. Some sample fields will be physically visited, and the area will be some 1 square meter area yield will be estimated. Based on that, there is a method by which we used to calculate yield. What will be our estimated yield by the end of the season? So it is not very accurate. It is very difficult. It is time-consuming, laborious process. Now it has become very easy. It started in 1970s with the availability of satellite images. So years, now we are able to get very high spatial resolution, high spectral resolution images became available. Now a number of free sites are also available wherein you can download your satellite data. So yield prediction and production forecasting, now we have images that are produced with electromagnetic wave reflection, and different vegetation indices are calculated from these images. And based on these indices, the most important indices like harvest index, photosynthetically active radiation, a number of indices are used by which we are able to calculate the total biomass as well as the yield of quite a good number of crops. And a number of models are also used along with the remote sensing data need to be interpreted that for estimating the biomass or yield, for which a number of biomass estimation methods are available. 3 different methods are available. I have not given all these details, and one of the most commonly used method is the crop growth model and Montieth model, 2 important methods. Crop growth modeling, most of you who are listening to this talk, maybe, I don't know whether you are aware, model, just like a computer program, a crop models are also available for most of the crops, for rice, for wheat, for cassava, for potato, for majority of the crops. Now crop models are available, which it is nothing but a computer program, but it behaves exactly like a crop in the field. In the computer itself, you can conduct experiments, you can conduct trials, you can apply fertilizers, you can apply irrigation, you can estimate based on which you will be able to predict how much it is going to give the yield in this location or in that location. So such kind of very accurate crop models are available, crop growth models. Cassava also, CTCRA has developed crop growth models with which we are now working on and developing a number of management tools. So crop growth models are developed based on complex interaction of different physiological processes. The direct use of remote sensing data to derive a variable assumes that remote sensing data are available at an adequate time step. And due to cloud contamination and intrinsic properties of sensors, this is rarely the case. Gaps between dates must therefore be filled by some interpolation procedure. Then second is a very famous model is Montieth model. So in a Montieth model, biomass is calculated based on the photosynthetically active radiation multiplied by a coefficient that is called the light extinction coefficient. That is the light use efficiency in units of biomass in megajoules. So, and based on that, once you get the biomass, that is the total biological yield, then how much will be the economic part of that total biological yield? You can calculate by multiplying biomass with the harvest index. For example, in the case of, I will tell a very simple example. In the case of tapioca, if you know the biomass, suppose it is say 80 tons per hectare. From 1 hectare, the total biomass, leaf, stem and tuber is 80 tons. Then how much will be the tuber part? For each variety, you have a harvest index. Harvest index means what is the proportion of the tuber divided by total biomass. So on an average, it is about 0.5. So if the total biomass is 80 tons, the tuber yield will be 50 tons, 40 tons. 80 into harvest index is 0.5, 80 into 0.5, it will be 40 tons. So based on this kind of estimations and formulae, you will be able to estimate what will be the yield of the standing crop at the end of the season, based by estimating with the help of use of, for which you need remote sensing data. Second, you need this kind of crop models and other models, and that will be analyzed in the software GIS platform. So I'm not going into the details of all these calculations and all. You just, at least for your understanding, that remote sensing has got a very big area of application in yield estimation. This is a study, satellite production forecasting of potato. A study was conducted. It is from a published paper I have taken. They have used remote sensing data, AirDAS Imagine software, these softwares were used. NDVA values were worked out. Finally, this processed NDVA data are analyzed spatially using ArcGIS environment. And just to know what will be your result, what you are going to get, you will be able to get in different places, what will be the yield, how much area is there, what is the, also all such kind of information you will be able to get. And finally, the average production forecasting also you will be able to know for different regions. And you can know in different province or in different districts what will be the yield, what is the range in yield. This is a website. You can interested if you can see this Government of India Ministry of Agriculture website. Mahalanobis National Crop Forecast Center. I have told that in India, for many of our major crops, we are actually doing the production forecasting. So if you go to this site, you will be able to know, and you will be able to get the information related to such a production forecasting details. And another important website which interested people can look into is FASAL, FASAL. That is forecasting agricultural output using space, agro-meteorological and land-based observations. There are also a lot of information is available. Those who are interested can look into it. Then we have also another site called NADAMS. That is National Agricultural Drought Assessment and Monitoring System. So this is also very, very widely. These three are three important sites websites that I am introducing to you. Those who are interested can enter into this site and see how actually remote sensing data is applied in the field. Now, there is a very famous site of farmer. Government of India has a farmer site, farmers portal. A lot of data is available in the farmers portal. So in that, this NADAMS will come. So this drought assessment monitoring, which place, which country, in our country, in which district, whether there is a possibility of having a drought. So how to manage drought in case of a drought. So all these advisories are also available. Farmers can make use of all this information. So number one, crop acreage. Number two, crop phenology. Number three, yield assessments. And number four, another major area where remote sensing is being applied is disease management, insect attack, and weeds. These are the three important biotic stresses that crop growth or agriculture is facing. Number one is pest attack. Number two is insect attack. Disease, insects, and weeds. These are three major problems that is actually affecting the yield of crops. Here, just like some examples I told now, in the case of cassava, the top right figure shows the attack of spiraling whitefly. The entire leaf, especially the backside of the covered with a white powdery-like material, and small insects can also be seen. This is a very serious problem nowadays in the last 3-4 years. And then on the left side bottom, you can see a virus disease of tapioca, cassava mosaic virus. That is also a very major problem in many areas, and that is also related to temperature, humidity, and a number of factors, cassava mosaic disease. Then weeds, the bottom right, you can see this is a cassava field, but it is fully covered with weeds. For cultivating about 1 hectare of tapioca, the farmer may have to spend 1,25,000 rupees towards expenditure, of which about 30 to 40% of the expenditure sometimes will go for weed management. He may have to remove the weeds by employing laborers, sometimes 3, 4, or sometimes 5 times. So that is a situation in some places. So weed management is a major problem. So we need to know all these crop stress factors well in advance, for which also the remote sensing techniques are used, in which the principle used is we are measuring the spectral reflectance of a healthy vegetation as well as a diseased vegetation. So based on these two information, spectral reflectance of healthy vegetation as well as spectral reflectance of a stressed vegetation, you will be able to know the extent of the disease, the extent of the pest problem. So a number of information can be derived using remote sensing data. This shows the change in the reflectance from a vegetative surface due to drought, water stress. You can see a healthy green vegetation. That green colored line graph shows the reflectance pattern in visible, near infrared, and infrared region of a healthy green vegetation. But a stressed vegetation, you can see that orange graph, the reflectance is different especially in the near infrared and short wave infrared region. And coming to severely stressed, again you can see the yellow graph. It also varies at the near infrared, it is different. At the short wave infrared, the reflectance is higher. So by distinguishing all this information, you will be able to distinguish whether in a plantation, whether a particular area is having a healthy vegetation, whether some of the patches are with the stressed vegetation or severely stressed vegetation due to pest attack, due to disease attack, due to weed infestation, and all this information can be derived. So monitoring and warning system for crop disease, crop insects, crop weeds must be constructed to manage and monitor crop diseases, insect pests, weeds, etc. This is a lot of applications are actually it is being used in the ground level. This is a study on delineation of diseased tea patches, especially in tea plantations and all. The number of pest problems are there that will actually totally defoliate the tea plantations. So in such cases, remote sensing data will be able to very easily distinguish the diseased areas, affected areas. Healthy areas are shown here in red color, moderately affected areas in green color, affected areas in a slightly brown color. So such kind of delineations can be made using remote sensing satellite data for understanding the infection of diseases or infestation by pests or weeds. So this is about crop disease, insect and weed monitoring, number 4. And there are quite a number of few other major applications also for remote sensing. I am basically a soil scientist. So soil science, in soil mapping, that's a major area where remote sensing data are used, the soil classification, soil taxonomy, then soil survey. In all these areas, remote sensing data are used. Just as I told in the case of the structure of a plant, in the case of soil also, here also the difference in the spectral reflectance curve that is used for delineating different types of soil. So the spectral reflectance will vary depending upon soil moisture, depending upon the soil, the content of sand, silt, clay, the differences. So all this will affect the spectral reflectance curve in a soil. So based on this principle, we will be able to distinguish different soil types, soil moisture content and all. So that is the basic principle of application of remote sensing in soil classification. This figure shows this is a different types of the 4 different types of soil. You can see the content of sand, silt and clay are different. So here the spectral percentage reflectance varies depending upon the texture. When the texture varies, the reflectance varies. When the moisture content varies, 4% moisture, 5 to 12% moisture, 22 to 32%. So depending upon the moisture content again, the percentage reflectance varies. Depending upon the clay content again, the percentage, the reflectance varies. So using all this information, we will be able to classify soils, group soils, identify soil types and all. So soil mapping is a very old story. FAO, the Food and Agriculture Organization of the United Nations, they have published soil map of the world. Entire world soil map is available in a very large scale, 1:5 million scale. Then in our country also, soil maps are available, and if you want to have a soil map of a particular region or a particular place, you need to contact the Survey of India office. Survey of India office is headquartered in Dehradun. In India, in Kerala also we have Survey of India office. If you want to have the topo sheets or cadastral maps of a particular district or a particular place, you have to go to the Survey of India office. In Thiruvananthapuram, there is a Survey of India office, and if you approach them, you will get such kind of maps, and those maps can be used for your studies. And remote sensing maps, if you want to have, there are a number of agencies. The most important one is NRSC, National Remote Sensing Center. NRSC is located in Hyderabad under Indian Space Research Organization. So they are the major providers of remote sensing data, remote sensing images in our country. So these are some basic theories about soil maps. I believe that soil survey, I have already, then we have an ICR Institute, National NBSS and LUP, National Bureau of Soil Survey and Land Use Planning. They also have prepared the soil maps of our country level map, then state level maps are available, district level maps are available, even village level maps are available. So information on, by approaching these agencies, if anybody is interested to have soil maps or other kind of maps, you will be able to get. So the first satellite for soil studies was launched in 1972. That was Landsat 1. Now, a number of satellites, ISRO has launched later on a number of satellites exclusively for soil studies, climate studies, meteorological studies. Different kinds of satellites are being available. And IR 1C, 1D, LIS3 data are available now after every 24 days. Then SARAL, Cartosat, RESAT. RESAT is a microwave satellite. Then Landsat 8. These are some of the common satellites whose data is used in the field of agriculture. So far I was talking about the soil mapping of a large areas, district or village. But if you want to have a farm mapping of your farm of 100 acres or 50 acres, so that also you will be able to do farm mapping. Just in city CRI, we have done a farm mapping of the city CRI farm. Actually, it is a geoinformatics GIS application. Just we have analyzed a number of points, collected soil samples from about 150 points in city CRI farm, and based on the point information, we will be able to extrapolate the data to not collected. Different methods are available. One of the most common method is known as kriging, Geostatistics is the broad area of analysis or interpolation of data using spatial data by statistics is known as geostatistics. And under geostatistics, there is a very common method or commonly used method that is known as kriging. So using kriging, you will be able to interpolate, for example, soil pH or nitrogen or phosphorus or potassium, whatever you are analyzing, you are collecting sample from specific points and analyzing. So based on that point data, you can extrapolate the values to the entire farm or entire field. A number of methods are available. So by which we have also analyzed the soil data of our farm for different parameters, and it is published, and that is made available in a decision support system for our internal use. The entire farm management, application of nutrient fertilizers, and all those activities are done based on this data prepared using this geostatistics and kriging method. So if anybody is interested to have soil related maps and data, these are the agencies from where you will be able to get the most important one I told is Survey of India. Survey of India headquarters is in Dehradun. Then you have NBSS and LUP. Bhuvan is a very popular site. That is a NRSA told National Remote Sensing Center in Hyderabad. You can those who are interested in doing research and all can just have a look into these websites, Bhuvan websites. You get a lot of satellite data. Then we have in Kerala State, we have a Kerala State Land Use Board. So this Kerala State Land Use Board also provided some data for your studies related. Then, as I told, if you want cadastral map, that is very large, small scale, small area maps, then you have to approach. For example, if you want a village, Srigarya village or Kottayam, some village, then you need cadastral map. So for getting cadastral map, you have to contact. There is a Directorate of Survey and Land Records. That is also in Sastamangalam in Tiruvanaന്തപുരം. If you request, they will provide you the cadastral maps. Then NRSA is the major agency. Currently, a number of satellites are in orbit and they provide data on payment basis. And some old data may be available free of cost also. And besides that, we have a lot of foreign satellite data through NRSA, Landsat, ERS, NOVA, Terra, Spot, RadarSat, Econos, CubeBird, NVSat. So a number of such data are available. So once you have this soil data, I told farm mapping we have prepared. So if you have the remote sensing soil data is also available, I told, from NBSS and LUP. And if you can, based on that, you can prepare nutrient management plans for one district, village level, different, that is called site-specific nutrient management. You can go for a field-specific nutrient recommendations, water management, or whatever crop management you want. Such a kind of maps you will be able to prepare based on different layers of data. One of the layers can be the satellite data or soil data that you have acquired from NBS and LUP or some other place. And finally, just last one more area where not remote sensing and especially geoinformatics as a broad subject has got a lot of applications. We know that our climate is changing. If you see the last from climate change is now a reality in the field of agriculture, and that is affecting the crop growth yield in a very significant way. The most important climate change effects especially in our state or our country are: number one is drought, that is shortage of water. Number two, high temperature, elevated temperature. Then the irregular pattern of rainfall, that is very important. For example, in our state, the total rainfall is still 2,940 mm. There is no shortage of rainfall, but if you see the number of rainy days, it is less. If you see the rainfall received in a particular day, it will be very high in some days. So this kind of irregularities in rainfall pattern is also affecting. Then the onset of monsoon is changing. Earlier, July was the most rainy month in our state. Now August or September is the most rainy month. Maximum rainfall is received during August, September, not in June or July. So our cropping system, cropping pattern and all, we need to adjust based on this climate change. So in order to understand the future, what will be the climate or what will be the impact of the change in climate by 2030 or 2050 in for cassava cultivation in Thiruvananthapuram district or for rice cultivation in Alappuzha district, how much it is going to affect due to climate change. I'm just telling in a very simple terms. So these are the intentions of climate modeling studies. So a number of models are available: EcoCrop, CropVat, a number of models. I'm not going into the details. Just for the audience, I just wanted to tell that in climate change modeling studies also, remote sensing data are used along with the other geoinformatics tools to predict and to understand how a crop will be affected in a particular year 2030 or 2050. How much will be the percentage yield reduction or yield increase by the year 2030? So such kind of what will be the change in major areas, how it is going to affect in major cassava growing areas in India, how it is going to affect by 2030, whether the yield will decrease, whether the yield will increase, which area will become unsuitable, which area will become more suitable. So such we have also this figure shows some of the such studies that we have conducted for different crops: cassava, elephant foot yam, yams. These were done by different PhD students in our lab. And currently we have two programs. One is DST Women Scientist Program and another KCST Women Scientist Program. They are all working on understanding the impact of future climate on tuber crops in major growing areas of India. This is a model, Max. This is one of the studies that we are currently doing to understand the climate suitability of tropical tuber crops using a model called Maxent. That's a very popularly used ecological model for understanding the future suitability of crops, how the future climate will affect the yield of crops. So these are some of the results that just I am not going into the detail, just to make you understand what are the prospects or what are the areas where we can use the remote sensing and geoinformatics in agriculture. Here this shows what is the present suitability of cassava, which are the areas that are more suitable, green areas are more suitable. By 2030, how it is going to change. So you can see that many areas are going to become more suitable for cassava, especially in this south and southeast regions. So again, for 2050, what is the change? So such kind of studies are possible. This is for another crop, sweet potato, we have studied. For different crops we have studied. I am not going into the details. So such kind of climate suitability studies are also possible with this kind of geoinformatics data. This is for elephant foot yam. This is for taro. So all this we are publishing in very highly rated international journals also. For comparison, we have analyzed the rice and potato also. And our results show that the percentage increment in yield, in different varieties, it varies. There will be yield reduction for cassava. In some areas, there will be yield reduction minus 14%. In some areas, there can be yield advantage of maximum up to 13%. So such kind of information, which area will become more suitable, which area yield is going to reduce. So all this information will help planners, policymakers, and other decision makers to grow crops in future based on this information. Now coming to my last slide, that is the future prospects. I have not prepared much slide on future prospects, but just I want to inform or tell you that remote sensing and GIS, GPS together called geoinformatics, along with the Internet of Things, then big data analytics and artificial intelligence. Now we have a group of scientists in CTCRI. We have a computer modeling scientist. So we are developing artificial intelligence enabled devices. You people might have read in paper that I have not gone into such details. Drone based applications. Drone, that is unmanned aerial vehicles. Drones are now used for application of fertilizers, application of pesticides, even for identification of some pests or diseases. drones are being used, and a number of startups and a number of companies are now coming in with the different tools and methods. In India, in Kerala also, very recently also we have tested application of fertilizers using drones in rice fields. So here also now new methods are coming with by which sensors are used. Sensor based artificial intelligence enabled devices are coming where also remote sensing data is used, and what do you call real-time decisions are made. Drone is flying, and in the real-time decisions are made whether one area needs more fertilizer, whether another area needs less fertilizer. So such kind of real-time decisions are made, and crop management can be adjusted. So these are all going to revolutionize Indian agriculture or world agriculture in the next coming few, not even 5 years, in 1 or 2 years itself, it is going to revolutionize, and already it has been in practice in many countries outside. In our country also now we are going ahead with a lot of research and developments in applications of remote sensing in the field of agriculture. So recently aerial, I have told, that ground-based platforms are also used. So remote sensing has got a very good prospect in addressing the problems in the field of agriculture. Thereby, we will be able to meet the food and nutrition requirements of the 150 crores of Indian population. That 150 crores, I think, we will be hitting by 2050. So all these modern technologies will enable us in meeting the food and nutrition requirements of our country. So with this, I conclude my talk, and I thank the organizers for giving me an opportunity to talk about this subject. Thank you all.
Thank you so
Yes,
much, sir. It
Madam.
was a very informative session. Now, it is the time to get into our question answer session. There are some questions in the chat box. Can I read it out, sir?
Yeah, please. I didn't see that. Okay. A few questions are there. Is soil mapping facility possible in all type of soils? Yeah, soil mapping facility is not related to soils. You can do mapping of soils for any kind of soils. Different methods are used. Manually also in small areas we are mapping. Nowadays, I told you, remote sensing satellite data are used, and a number of data and layers are available for mapping of soils, by which we are able to classify. There is a subject called soil taxonomy, in which soils are classified into 12 different groups. Just like plants are classified, plant taxonomy, soils are also classified into different order, suborder, grade group, subgroup, family, and series. So all these processes are done for all soil types using this kind of data. Okay, thank you. Then Indira James has asked, is there any institution in Kerala providing remote sensing course? Yeah. And, as far as I know, there is an institute called the Indian Institute of Information Technology and Management. You people might have heard, IITMK, Indian Institute of Information Technology and Management, that is located in Technopark. Now it is going to be a separate university, which is called a digital university. IITMK, they have MSc, MTech courses in geoinformatics. And one of the best courses is offered, but not in Kerala. It is the Indian Institute of Remote Sensing. That also I forgot to mention. There is an institute called IIRS, Indian Institute of Remote Sensing, that is located in Dehradun. It is under ISRO. Two master's degree courses. One is MSc Geoinformation Science, and another one is MTech Geoinformation Science. Both are almost same. MSc Geoinformation Science course is actually a joint program of IIRS and a Netherlands university, that is called ITC, Netherlands. So if you are able, but you may have to go give a little higher fee. 3 months you can go to Netherlands for your project work. And the degree also will be awarded by that university in Netherlands. And MTech is again a 2-year program. That is, I think the degree is offered by Andhra University. Both are almost same, but MSc course, you need to pay a little higher fee. You have to meet the expenditure for going to the Netherlands and coming back. That is another. That is the IIRS. Then in some central universities, I am not very sure which university central are available, where also remote sensing MSc and PhD degrees are available. Bharatiya University, some universities are there. Okay. Then is there any negative impacts about remote sensing? Negative impacts about remote sensing, I am not sure whether I am able to answer that. Is there any, how has remote sensing changed the world? That I think I have already answered in my last place. Remote sensing, you people now are the beneficiaries of remote sensing in your day-to-day life. That I have already told. Your mobile phone, there is a remote sensing application. All your Google Maps, I told now, whatever you need to find a shop near me. Where is the Lulu? Where is this shop near me? Or where is the shoe mart near me? Everything you are finding with the application of remote sensing. So it is a disruptive technology. There is a terminology. One of the disruptive technologies is this remote sensing satellite data and its applications. Agriculture also has got an application. That's all. Actually, this geoinformatics was developed in the field of defense by US Defense, United States Defense Department. First they started this. Their aim was to target any bomb or some warfares to the exact location they want to pinpoint. So that was that was the field in which it was initiated. Later on, they gave that facility for in other fields also, like agriculture and all other fields. Now, India also has launched a separate satellite system for our navigation. And it is not fully operational, but still we are using the US GPS system. So, remote sensing has totally changed the world. That is my feeling. Can we detect drought? Yes. That I think I have made drought, flood, even Kerala flood time also, remote sensing data was used. And in drought monitoring, I told them NADAMS, there is a website. It is widely practiced. Just you go and see the websites, then you will be able to understand how much we are able to practice, how much we are actually practicing these technologies. And every day, the technologies, the algorithms, the artificial intelligence enabled tools and algorithms are coming every day by day. Research is going on a very fast pace. And in the near future, all this will have now the level of accuracy may be slightly less in some areas, but we will be able to increase the accuracy to the fullest extent with the interventions of this AI. AI is a tool. Artificial intelligence is another disruptive technology that you are going to face another 1 or 2 years, which is going to come into all fields of human life. Is remote sensing in agriculture is completely a success? I told that when I was a student, this question was, I used to think and discuss with my colleagues because it was not at all applied. But when I look back 30 years ago and now when I think, I see that remote sensing is being applied on a large scale, at least in some areas. I told in crop forecasting. You can see the website. Our country is using. We are not it is not in theory. In yield forecasting, our country is using. Drought monitoring, our country is using. Even in meteorology, I have not touched weather forecasting. So all these kinds, it has got a very high level of accuracy compared to previous years. So do clouds affect spectral response of thermal band in remote sensing? Definitely clouds will affect spectral response of thermal band in remote sensing. But there are tools, there are methods by which we will be able to remove such errors. And sometimes you may have to collect data. Cloud-free dates also you have to find out and you have to take. Even otherwise also there are a number of tools by which such errors can be eliminated. How can we apply remote sensing in greenhouse to know about the humidity? I think in protected cultivation, greenhouse is the kind of protected cultivation. In protected cultivation, now a number of sensors are available, not satellite data, but sensor-based data. That is also remote sensing. Now, mostly remote sensing is in the field. Application of remote sensing is based on sensors. A number of sensors are being developed. Now, soil sensor is being developed. Just by pressing a probe into the soil, we will be able to know what is the nitrogen, phosphorus, potassium, all contents, just at one stroke. Now it is not available, but research is going on. In the near future, we will be able to understand. There is no need to test, any chemical test is not required. Just by dipping or pressing a probe into a soil, you will be able to know. Now also it is available, but not for all. Just by one probe, you cannot know what is the N, P, K, calcium, magnesium, everything is not possible, but nitrogen is possible, phosphorus, individually it is possible. But now research is going on by which in the near future, such kind of devices will be coming and you will be able to know what is the content of. So similarly, in greenhouse also, these sensors are being used to not only to understand the humidity, temperature, moisture, all these are regulated. And such a sensor-based protected cultivation or high-tech cultivation is very common and widely practiced. And sometimes the owner or will be sitting in outside abroad, and he will be able to control irrigation or nutrition. He will be able to see how his crop is standing in the field in Bangalore. So such things are already available in the field. How can we know about the conditions of fruits through remote sensing? I told now that is crop phenology. Crop phenology I have already told, by which based on the change in the color of the fruit, the texture of the fruit, the moisture content of the fruit, the change in leaf pattern. So based on all this, in large farms like grape in Europe, or orange in US, or apple in Australia, so in such kind of big farms, these are being used, but not in our country, because the farming or agriculture in India has got a lot of differences with the farming in Western countries or developed countries, because most of the Indian farmers are small farmers, marginal farmers. 80% of the Indian farmers are small and marginal farmers. So farms are very small. So in such farms, though this kind of technologies were not used earlier, now we are coming with this unmanned aerial vehicle, drone-based technologies and all, so with which we will be able to address the problems of the small and marginal farmers also. So thank you.
There are no more questions in the chat box, sir. So very thank you.
There are,
As we are getting
okay,
out of
madam.
time, we will end up the question and answer session and wrap up with feedbacks. Now, I invite Ms. Anu Lawrence, BSc Microbiology, for the feedback.
Firstly, thank you, Dr. G. Birsa, for your really informative session. As we hear, remote sensing in agriculture is a process by acquiring information about the Earth's surface by measuring its reflected and emitted radiations without coming to direct contact with the object. Remote sensing has the capacity to assist the adaptive evolution of agriculture particles in order to face their major challenges by providing repetitive information on crop status throughout the season at different scales and for different actors.
Thank you, Anu. Now, I invite Ms. Devika Pia from MSc Microbiology for the feedback.
I would like to thank our beloved Dr. G. Baijusa for such a wonderful and delightful session. This talk was most effective and all can gather the information about the remote sensing and its role in the field of agriculture. Remote sensing is the acquisition and measurement of data or information on some properties of a phenomenon, object, or material by a recording device not in physical intimate contact with the features under surveillance. In the field of agriculture, it has focused many significant uses. There are very many applications of remote sensing in the agriculture sector. They are crop area estimation, crop phenology, yield assessment, crop disease, insect and weed monitoring, soil mapping, climate change modeling. I found this meeting really helpful and this session was most enjoyable and highly informative. Thank you. Thank you so much, sir.
Thank
Thank
you.
you, Devika. Now, I invite Professor Subi Beers for the vote of thanks.
Good afternoon, everyone. Today, I, Subi take the opportunity to put my gratitude in the form of words. Let me first of all start by giving glory to Almighty God. Only because of His blessings and grace, we are able to conduct this webinar without any obstacle. On behalf of Indira Gandhi College of Arts and Science and the entire fraternity of Bioscience Department, we are happy to declare our thankfulness to the resource person, Dr. G. Baidu, Principal Scientist of Central Tuber of Research Institute, Trivandrum, for accepting our invitation and taking out time from his schedule and enlighten us with knowledge. Today's webinar gave deep insights into the topic and also revealed some interesting facts. I'm pretty sure that the precious knowledge that sir shared will definitely help us in our future. Thank you so much, sir. Wholeheartedly, I must thank respected Sir Dr. C.V. Thomas for his valuable support and all time and motivate us for conducting this webinar. Thank you, sir, for guiding and encouraging us. I would like to take this opportunity to place on record our sincere thanks to our beloved HOD, Ruby ma'am, for her support and guidance she has extended to all of us. With a deep sense of appreciation, I thank the entire crew of our Bioscience department for their dedication and hard work in organizing the webinar. Especially, special credit goes to my colleagues and organizing partners, Professor Gina Sebastian and Professor John Joseph, for all the digital support in creating the invitation and poster for this webinar. We are immensely grateful to the management team of Indira Gandhi College of Arts and Science for sponsoring this webinar and also take this opportunity to extend our special thanks to the IQAC of our college for their valuable cooperation in conducting this webinar. Moreover, I am very glad and thankful to all the participants valuable trust and highly appreciate. Once again, thank you for your attention. Have a good day.
Thank you.
Thank you, ma'am. Now, it is the time to conclude our webinar session. Once again, thanking you all for taking your time out from personal and professional schedule to make this webinar a grand success. Thank you and have a great day.